In 1859, telegraph machines caught fire while the power was switched off. Operators ripped out the batteries. The machines kept transmitting anyway, powered by the sky itself. Outside, the night sky turned crimson and green. Auroras blazed as far south as the tropics. Birds began to sing at midnight, and people woke thinking morning had come. This was the largest solar storm in recorded history, the Carrington event. And if it struck today, it could switch off the modern world. Here's the part that should worry you. In 1859, there was almost nothing to break. Today, everything runs through the two systems a solar storm attacks: the power grid beneath your feet and the satellites over your head. To see how a star could kill both at once, look at what the sun really is. The sun looks calm. It isn't. It's a churning ball of superheated plasma, wrapped in magnetic fields that twist, snap, and explode. When those magnetic fields snap, the sun hurls a coronal mass ejection, 1 billion tons of magnetized plasma flung into space at over 3 million miles an hour. 3 million miles an hour sounds survivable until you realize it crosses 93 million miles of space and reaches Earth in less than a day. Most miss us. Space is big and Earth is a tiny target, but every so often, one is aimed straight down the barrel at us. So picture the day one does. A telescope catches the flash. We get a warning, but the storm is barely 18 hours behind the light. When the cloud arrives, it slams into Earth's magnetic shield and crushes it inward. That shield is the only reason we survive. But squeezing it has a violent side effect. A shuddering magnetic field induces enormous electric currents in anything long and metal. And nothing is longer or more metal than the power grid. This isn't hypothetical. In 1989, a far smaller storm hit Quebec. In 90 seconds, the currents fried the grid and plunged 6 million people into darkness. 90 seconds for a storm a fraction of Carrington's size. Now scale that up to the real thing and stretch it across entire continents at once. Now for the twist. If a Carrington storm hit today, the blackout wouldn't be the disaster. The disaster is what doesn't come back. The grid runs on giant transformers the size of houses. Those surges don't just trip them, they physically melt them from the inside. Here's the catch. The biggest transformers are custom built to order, weigh hundreds of tons, and take 1 to 2 years to make. We don't keep spares, lose hundreds at once, and there is no fast way back. And everything else runs on that grid. No power means no water pumps, no fuel pumps, no refrigeration, no payment systems. Within days, not weeks. The Victorians of 1859 lived through the largest storm in history without a scratch. A modern city stripped of power for a year might not. If this sounds like a distant maybe, it isn't. In July 2012, a Carrington-class storm erupted from the sun and tore across Earth's orbit. It crossed exactly where Earth had been just 9 days earlier. 9 days is the only reason you've never heard about it. Scientists estimate the odds of a Carrington-level hit at over 1% per year. Given enough years, 1% is not a comfort, it's a countdown. We can't stop the sun, but we're not helpless either. That 18-hour warning is a gift if we use it. Operators can deliberately power the grid down before the storm arrives, because a grid that's switched off has nothing for the currents to destroy. A short, controlled blackout to prevent a year-long one. The only question left is whether we'll act fast enough when the warning finally comes. Because the next time the sky glows crimson at midnight, it won't be a wonder to marvel at. It will be a warning that the storm has already arrived and the modern world is about to switch off.